Good afternoon and welcome everybody. Wow, there is nothing sexier than solar at the moment, and today we are super excited to be bringing you a webinar on just that. Voltex offers an incredible range of solar and renewable products throughout our 58 branches nationwide, as well as on our online store. So please do have a look at what we've got. In the meantime, I'm going to see if Jacques is ready. Jacques is one of our internal solar specialists. Hello, Jacques.
Hi there.
Hi, and thank you for joining us today. Thank you to each one of you that's joined us. It's incredible to see all these new names, as well as our regulars. Thank you again for joining us. And hello to each of you. And please note, we will be having a Q&A session after the presentation. So please do leave your questions throughout, and we'll address them towards the end. I'm going to hand over to you, though, Jacques. It's all up to you now.
Thank you. Hi, everyone. Thank you for attending the basic solar and backup system identification and selection. This is a brief view into our beautiful world of alternative and renewable energy. This is more aimed towards giving you ammo going forward as contractor, even as consumer, knowing more of what's going on in the world of solar and backup systems. Just get my system sorted here. Right, here we go. Basic solar and backup system identification and selection. Firstly, we're going to start off with the different types of systems. Backup UPS system, off-grid systems, hybrid systems, DC coupled, AC coupled, or combined, and grid tie systems. Backup system is purely an inverter and battery connected to your line, dedicated loads to cater for power outages. Off-grid system is where there is no mains available. So it will be purely batteries, inverter, and solar powering all of your loads. Hybrid systems is a combination of technology. So you can use MPPT chargers, grid tie inverters, or a combination of both to run along with your utility power, providing savings as well as carrying your loads during outages. And then finally, the money saver, the money maker, grid tie systems. A system that synchronizes with the utility to feed in power to your loads, and ultimately, if you are allowed in an area where you can export for a rebate or for zero metering. Just a couple of terms that I want to go through before we carry on to make sure everyone is on level with the terms that we use. AC, alternating current, DC, direct current. UPS is uninterruptible power supply, inverter, MPPT, AC coupled, DC coupled. Alternating current, most common use sort of power that we use in everyday home businesses, factories. DC, direct current, mostly supplied by batteries, alternative energy sources, or alternatively also on main lines. UPS, it's a system that automatically switches from mains to DC power, converted back to mains to power your loads in the event of a power outage. Inverter is a machine that converts the DC power, battery power, to AC. MPPT, maximum power point tracking, that is a method used to provide the maximum amount of solar power available at any given time. AC coupled is utilizing battery inverters and grid tie inverters combined to power your loads and charge batteries. DC coupled is by using an MPPT charge controller to charge your batteries directly and utilize excess load via the DC side of the system, called the DC bus, to power loads as well. So, step one, identify the requirements. when approaching a customer or when approaching the alternative energy solutions in general, you need to ask the following questions. Is power supply an issue, like load shedding, constant outages, or zero supply? Is power expensive and is savings required? Which in most cases it is. Is power just expensive and unreliable? So, question 1, a backup system, hybrid system, or an off-grid system should apply. Is power expensive and is savings required? That's purely a grid-tied system. And is power expensive and unreliable? That would be a hybrid system. So what I've done is I've made a couple of demonstration models for the different types of systems to show you what is possible and what can be done with alternative and renewable energy. So first we have a backup system. Most common sort, as we have load shedding, it is a big issue in our country. Firstly, you have your load and Eskom. So as a standard, there's a direct connection between the two. Now with the backup system, we add an inverter and battery system into the equation. So by tying up the inverter with the battery, it generates AC power, and Eskom or mains can also feed through the system and charge the battery. In the event of a power failure, you will be running purely off the battery system until the mains come back on. So when the mains come back on, battery will be automatically charged through the system, and the power will be bypassed through the system to your loads as well. The next system we're going to play with is an off-grid inverter system. In an off-grid setup, you only have loads. You do not have utility. So once again, battery and inverter generating your AC setup. But with this system, we add solar modules to the equation. As you do not have mains available, you need a source to charge your batteries in order to power your loads. So when the sun comes up, your system starts generating power from your PV modules, charging the battery and carrying your loads. When the sun sets, the inverter and battery setup takes over and carries your loads. Our second toy would be a hybrid inverter system, DC coupled. And before I start with this one, there's various different types of inverters. So this one's specifically on the Voltronic inverter, being a hybrid system. Hybrid meaning you've got multiple sources of energy. So as per norm, you have your utility and your loads. You've got the battery system that we connect and your system that feeds through. By adding solar to the equation, you can supplement power from PV to your loads and generate a saving on your Eskom account. After hours, the system will carry on as normal. You can consume a certain amount from the batteries. Then mains can take over once you've reached that program threshold, which also in Eskom fails, like a UPS system, you will revert to battery power. If Eskom fails during the day, obviously the solar system will generate power, charge the battery, and also supply the loads. Going to our next system, it's also a DC coupled system, but this is with a different brand of equipment, also a higher end brand. So similar to the rest, you've got your loads, you've got your utility, nice shiny blue inverter. With this inverter, it is not a hybrid inverter. This is a bidirectional inverter, so also known as a battery inverter or an inverter charger. By adding a solar MPPT charge controller to it, you can charge batteries directly and surplus power can be fed to the loads. In the event of ESCOM failure, once again, reverting to batteries, the inverter will change the DC power into AC power, keeping your loads covered. During an outage, during the day, the solar will keep the batteries charged and it will also keep your loads powered up. Hybrid systems, AC coupled. Now, AC coupled is also a beautiful toy that it serves a certain purpose in the market. It's not the most common way of doing it, but I'll explain as we go along what it is intended for. So once again, you've got your inverter and battery set up. This adds a grid tie inverter to the equation. So the grid tie is connected to the output of your battery inverter. Thus, in the inverter generates a 50 hertz frequency, giving the system the frequency to power up and feed power to your loads, and in turn, feed power back to the inverter. And as I mentioned earlier, this is a bidirectional inverter. So the excess power fed back that is not being utilized by the loads can be fed back into the inverter and the batteries can be charged from this source. When your sun goes down, you revert to basic settings, ESCOM pushes through, carrying your loads, and the battery will be utilized in power outages. Also, during power outages, if the sun comes up and your system is still active, it will start the grid tie inverter and it will feed loads to your power to your loads and through back to your batteries. So the combination of these systems it's intended for larger type systems deemed very effectively, whereas you need a specific amount of load that needs to be covered, and you've got a specific backup that you need to cater for. So the basic setup remains the same. The inverter and battery connection is still there. Your DC coupling takes place by adding an MPPT charge controller to the equation. And then the AC coupling side runs along with it. So your AC inverter is designed for specific loads, to power the loads directly where the loads are powered. And the charge controller is there for two reasons: to keep the battery charged, and also in the event of a mains failure, where the battery has completely discharged. Your MPPT is your fail safe, where when the sun comes up, the inverter with the charge controller will start charging the batteries, and when reaching a certain voltage, your inverter will switch on the power output, and in turn power up the grid tie inverter, enabling it to feed power directly to your loads and also in reverse back again to your battery for charging. In the event of mains failure, everything stays active. The sun goes down, you revert back to battery, like a UPS system. Grid-tied systems, not as common on domestic level as in commercial industrial, but there is quite the amount of homeowners that prefer this type of system. A grid-tied system is a money maker, money saver. It's a system that can ultimately pay for itself. So similar setup, you've got your AC line powering your loads. By adding a grid-tied system to the equation, you can feed power into that line. Now, in areas where you are allowed to export, you can export the power back for zero metering or for a rebate. In the event that you're not allowed to, and this is a preferred system specifically for domestic purposes and areas where you're not allowed to feed back, we add an energy meter to the equation on your main incomer. Now, the energy meter measures what is coming into the system, and it's got communication with your grid tie inverter. So it throttles the inverter to cater purely for the loads, and not all the excess power is then throttled. The downside on a domestic level and the situation that we're finding ourselves in with load shedding, with supply not being sufficient, is that if ESCOM fails, your grid-tied system, your wholesaler system, will be inactive. There's no battery inverter keeping it active, generating a 50 hertz frequency. The reason for this is, in the event of line maintenance and the contractor switches off the utility supply and they start doing maintenance, if this system stays active, it can reverse feed and it can cause harm to that specific contractor. Even if the sun shines, the system will not generate any energy, as it requires ESCOM or utility to power it up. Okay, step 2, site visits and what to look for. When doing a site visit, you will need to keep in mind of what the requirements are in order to know what to look for. So, a backup system site visit. Identify where the distribution board is. Make 100% sure that the DB is compliant according to the SAN standards. Identify where the system is to be installed. You need to calculate the cable thicknesses according to the requirements, and also identify where you're going to install the system to accommodate for your consumables. On a backup system, only certain circuits will be allowed to be powered up. We call it comfort loads: lights, fridges, television sets, internet routers, etc. So you need to identify if it is going to be possible to split the circuits between dedicated and non-dedicated, or essential and non-essential loads. You need to look inside the distribution board as well to ensure that there's space for a second earth leakage unit. This earth leakage unit will be specifically for your backup system. So also note, a backup system usually comes with a battery pack that requires some floor or wall space, and an inverter with its own distribution board, which also requires wall space. So make sure you've got enough wall space and floor space, or an allocated area for the specific system. Off-grid system site visit. Once again, know where the DB board is, make sure it's compliant. Identify where the system is installed. All the circuits on this DB board will be powered from the system. So a second earth leakage is not required. You can utilize the standard one. Off-grid system, as it uses solar modules, you need to gain access to the roof, look at the quality of the roof and the type of roof to calculate your roof mounting structure. So whether it's corrugated, IBR, tile roof, etc., you need to be able to look at the roof. You need to measure the pitch of the roof and also look at the direction in which the roof is facing, because we can generate power in Southern Africa from a north, east or west, or a combination of roofs. So you need to know what the pitch is. The perfect pitch will give perfect results. The lower the pitch, less results will come out of the system. Your system yield will be lower. So hybrid site visit, similar to off-grid, identify where the DB is, compliancy, where the system is to be installed, bearing in mind a hybrid system takes up quite a bit of space. It's not just a battery bank, there's additional boxes that come with it, other than the DB board. Measure the roof space. A hybrid system can be calculated to power the full load or split the load. So once again, you need to establish if there's enough space in the DB board for another earth leakage if you do load splitting, or in the event that you're going to run the whole system from the alternative energy source, you do not require space for an alternative earth leakage. You can run it through the main earth leakage. On a hybrid system, a backup system, any type of system, you need to insist on an energy audit, because you need to identify the loads that you are working with. And we'll touch base on the energy audit a bit later. Grid tie system site visit, pretty much similar to the rest, only that you do not need a lot of space because there's no batteries involved. The system is purely inverter and distribution board. On this system, similar to the others, compliancy, where the DB board is, where the system is to be installed. In this case, you need to look in the DB board and see if there's enough space for another circuit breaker to have access to that specific circuit powering your house from alternative energy. There will be a circuit breaker allocated to the unit in its own separate distribution board, but as added measure, we add another circuit breaker into the main board, or alternatively put a surface mount box next to the main board. If the system is not installed in close proximity of the distribution board, you would like to have access from where inside the house where the DB board is to easily switch off the system in the event of something going wrong. Once again, on this type of system, you need to insist on an energy audit because it will only make your design more accurate. It's no use thumb sucking values. It's no use looking at standard load. You need to do an energy audit because you need to establish where the peak consumption is, if it is in fact during the day. If your peak consumption is at night, a grid tie system will not be a benefit to your business, to your home, etc. Okay, energy audits. Backup, off-grid, hybrid systems. Off-grid being a bit harder to spec, but usually in most cases, off-grid systems are calculated on houses that want to go off-grid, they want to get rid of Eskom, or you can utilize a spec as well in that case. But in most cases, it is a retrofit system, whereas the consumer would like to get rid of the utility supply. With these systems, you're going to need an energy auditor that can show you kilowatt hours and kilowatt peak usage. We prefer utilizing the EFERGY meter as it gives us the sufficient readings in order to design a system. Grid tie systems requires a more involved energy audit to be done, as peak usage, time of use is also plays a big role in the calculation of the system design. We suggest a microsecond energy auditor so that you can see physical peaks and go into have an in-depth look at what the system is doing to spec it correctly. Example of the energy meters and energy readings. This is the common EFERGY report that you would get. On the left-hand side of your screen, you'll see the physical little monitor. That's the receiver unit that's got the monitor on it, and the sender unit with the CT, the current transformer, is right above it. The current transformer is installed inside your distribution board, and the receiver unit with the little monitor can be placed within 5 to 10 meters from the DB board on a fridge, on a shelf where you've got access to it. It gives you a good indication of what you're consuming at any given time while the unit is installed. And at the end of the day, when we need to do a system design, it gives you the usages that we require. So the first little block is the kilowatt hour. That is what we would use to spec the battery bank according to. The second block would show your peak consumption. This gives us an idea of what size inverter to spec. That's your maximum power. Example of a microsecond energy auditor. This is the brand we prefer using. And if you look at the graphs supplied, you can zoom into microseconds to look at peaks. We literally take the averages and look at a specific time of day, usually between 6 a.m. and 6 p.m. to see what your consumption curve is. And we utilize the software to zoom in to get that specific reading. And that gives us an idea. As this specific unit, you'll see it's got an average of around about 180 kilowatt. So that is what we would spec our system according to. Select and size the correct system. Utilize the information collected from the energy audits done to size the system or the backup kit accurately. Get in touch with your local branch regarding further training and more in-depth product training, as well as system sizing training that would be available soon via webinar platform. We used to do per branch or per region training. With technology on our side now, we will be doing webinars where you can also log in as you've done today, and you can get the relevant information on how to size the system, what to use, what platform you're going for, etc. You can also post your inquiries to solar@voltex.co.za, and we will establish where you are situated and route your inquiry to the correct branch and the correct person. Lastly, I would like to touch base on this. This is one of our first webinars we are going to launch. It's the GEYSER RETROFIT system. The system, you literally change the element of your geyser. This specific element has an AC element and DC element built in. So during the day, instead of the sun heating water, the energy will provide power via the DC bus to the element, heating your water during the day. And alternatively, you can utilize AC supply as well to heat it during cloudy days, or if more hot water is required at night. This system is an absolute brilliant setup. We've got bundles of these installed throughout the country already. And the main thing with this is you do not lose your warranty on your geyser if you retrofit with this element. But it's only on specific geysers, QuickHot being one of them. You do not lose your geyser warranty if you retrofit the system. We've already got the approvals from these companies in order to do retrofit systems on their geysers. Now, what everyone's been waiting for, Q&As. If you've got any questions, please post, or if you've already posted, we'll attend to it now. And let's see how we can best assist you with your inquiries. Okay, let's see here. I'm going to start from the beginning. What had happened, such municipalities versus charge example license for sun usage? Yes, there is talk about it. Certain municipalities, you need to register your system to answer your question, Naresh. You need to, before installing a system, you need to make sure that you've got the right authorization from your municipality or your energy provider. In certain cases, you've got municipalities, and others you do have Voltex direct lines. Excuse me. Where do we get the EFERGY meter from? Does Voltex have? Yes, absolutely. We do import directly. So EFERGY meters should be freely available from Voltex branches. Each EFERGY meter gives different readings or same. Justin Rankin, can you please elaborate on that question on the EFERGYs? I do not quite understand what your question was there. Okay. Adam Sinclair, seems my internet is lagging, I'm missing out. I'm sure we should have a link for this session available soon to you guys that you can review and revise. Let me see here. Are these webinars available on a website that we can watch at a later stage? Adam, it will be posted to a site where you can watch it later.
Apologies. Sorry,
Robin, just to confirm, there is a channel where they can view these afterwards?
Yes, absolutely. So we'll post all our replay videos to our YouTube channel, as well as we'll share the link to the replay video with everyone who registered for this webinar today. So if you did miss anything or had any technical issues, rest assured we will share the presentation, well, the webinar with you to relook. And I know you jumped into the questions there, Jacques. Just from my side, I wanted to say thank you for such an awesome presentation. My signal cut out there literally at the end, so I got the retrofit sneak peek, and that was it.
Okay, I'm going to continue with the questions, Robin.
Perfect.
Just make sure we work through all of them. Nikki Potrita, could you please send registered members to get a schematic drawing of the different types of systems? Nikki, drop us a mail at solar@voltex.co.za, and one of our consultants will provide you with the relevant drawings or schematics as required. Taste-free, what about grid tie inverter with battery backup? Grid tie inverter, that is also, it's a more involved system. It's a different type of system, but it ultimately boils down to a hybrid solution, whereas if you look at the initial slides on the DC coupled or AC coupled systems, that is what you're going to have to look at. There is systems available that instead of a normal MPPT, it's got a grid tie inverter integrated into the unit, and it's got battery power, battery connectivity, which we are exploring, and we would like to actually release something like that in the time to come. We are working with brands that are well known and that we've got a firm handover and we can repair in-house. So those units, we are looking into it, we are doing testing, and it should be available soon. Jacques Malone, will the Voltex inverter be approved for use in Cape Town in the near future? The Voltex inverter is an off-grid inverter. So the Cape Town list that I've seen is more towards based more towards systems that can actually feed back, like your VICTRONs. This is an off-grid inverter and can literally not feed any excess energy back to the grid.
We've got a couple more questions that have come in, and just to let everyone know, if you do have any questions, please do send them through now for Jacques to answer. Nadia here has said, do you guys also sell microsecond readings monitor?
That we can make that available to you through one of our sister companies called Impact Power. Microsecond energy auditors can be ordered via the Voltex branches. The one that I've actually shown on the presentation is very handy, and it's a next level type of solution. So definitely available. As I understand, we do have stock available in the country as well.
Great. And Nikki here just confirming, she seems to lost connection like I did, just asking about the diagrams of most systems available to revise and understand the different solutions. She's not sure if we answered this previously. Her internet is lagging.
Let's go up here. Nikki schematic diagrams of most systems available to and revise and understand the different solution. Not sure if you answered the previous. Internet seems to. Yeah, once again, that is drop us a mail at solar@voltex.co.za. We can provide you with these diagrams and route you in the right direction should there be any further questions.
Amazing. Just from my side, I just wanted to reiterate that you can shop Voltex, wide range of solar and renewable products on the Voltex website, as well as through our branches nationwide. You can get in touch with Jacques at that solar@voltex email address, or you can ultimately take a look at the offers that we've just launched. We have launched an offer for you to have a look at what's available on the Voltex website currently. Another question here just from Justin. He says, I have two EFERGY is meter that gives different readings, same apply. I'm not 100% sure what that would mean.
Readings on the same supply. Okay. That has happened in the past. It might be two firmwares, or it could also be that you have faulty current transformers. The CTs could be faulty. Maybe try the 1 meter CT on the other meter, or vice versa. It could be that there's software issues as well. The older units, I understand, weren't as accurate. The more recent, I think it's 2018 upwards, are running a later firmware inside. Okay, we've got.
You can see the question here from Jürgen saying element AC/DC for GEYSER wise retrofit.
The elements, all the components for the GEYSER systems are separately available or in kit base. So you can inquire from your closest branch or forward the inquiry onto us at solar@voltex.co.za.
That's it.
Yeah.
Jacques also did give a slight little tease to what is to come. So please do stay tuned to the Voltex website as well as our social media pages for more solar and renewable focused webinars in the coming soon future, near future there. But just again, from my side, just a huge thank you to you, Jacques, and for that amazing presentation. And thank you to each and every one of you who joined us. It's back to level 3, well, for the first time, level 3 regulations, I guess we can call it, and to have so many people joining us today is really awesome to see. So thank you so much. We do have more exciting webinars planned over the next coming days and weeks, so please do check out our website as well as our social media pages.
I see there's a new EFERGY webinar. We are working on the webinars on every single product that we are doing, and that will be available soon. So an EFERGY overall webinar regarding the meter readings, the installation of, etc., will be available soon. Stay tuned for that one. Awesome.
But thank you to each of you that are saying thank you. That's amazing to see all the awesome messages coming through. And as I mentioned, there will be a replay link made available. But for the last time, thank you very much, Jacques.
Thank you, and thank you everyone for tuning in and looking into what my everyday world is. It is very exciting. It's a market that grows daily and technology that grows by the minute. So we are very excited to go forward with the Voltex solar drive, and stay tuned for more to come.
Amazing.
And thank you.
Thank you. Take care, everyone.